Here are solutions to homework set number 5 for ECE 320. Now the goal in this one is to build a temperature alarm. When you're done, this is what it should look like. So turning it on. So that's kind of goal. I want to have something that turns on an alarm when it gets too hot. So to start out with, let's build a pipe timer. The purpose of this is to output a square wave that I'm going to then use to drive a speaker. So the output of the pipe timer, well, here's the basic circuit. And what happens is I charge the capacitor through R1 and R2. I discharge through R2. So the voltage at the capacitor should be doing this. Charge, discharge. To calculate the on time, I charge through R1 and R2, so the on time will be the sum of the resistors, times C, times log of 2. And where the log of 2 comes from is I'm going to drop by half. So this is an exponential decay, drops by half, take the log, you get log of a half, Anyway, that's the equation. So it should be on for 831 microseconds. I discharge through R2, off for 693 microseconds. Not exactly 50-50 square wave. So that's my pipe timer computations. Throw it in Circuit Lab, and here's what I get. I charge through R1 plus R2. I discharge through R2. And I can measure these times in Circuit Lab. And the on time, this is 11.3 milliseconds. This is 12.13 milliseconds. This is 12.84. Take the difference, I can get the on time and off time. So the on time is 830 microseconds simulated. I calculated 831. That matches pretty well. Off time is supposed to be 693 microseconds. I simulated, got 710. Yeah, not exactly as good, but still pretty close. So that checks out. I've got a pipe timer that's working. And what it did is I displayed this voltage across the capacitor and the output voltage. Second step, problem 3. I want to come up with a switch so that when this outputs a square wave, I turn the speaker on and off. So first I want to find IC. IC is your 5 volts minus 0.7 volts. Oh, 5 volts minus, when this is saturated, it's 0.2 volts. 5 minus 0.2 over 28 ohms. I should be getting 153 microamps or milliamps when it turns on. IB, this current, this is 5 volts when turned on. This is a diode. Voltage drop across the diode is 0.7. 4.3 volts across 1K, 4.3 milliamps. And it depends upon the transistor you use. If you use a 3904, the gain HFE, or we call beta, is equal to 100. It's actually between 100 and 300. Worst case, if you take 100, that allows 430 milliamps to flow. I'm only trying to push 153, so it saturates. And the condition for saturation is that beta IB, the current that I'm allowing, has to be more than I need. It's got to be more than 153 milliamps, and that checks out. So this should work. I should saturate the transistor, turn it on when this is 5 volts. 0 volts is pretty easy. When this is 0 volts, that's not enough to turn on the diode. No current through the diode, transistor turns off. No current through the speaker. So again, the speaker should be doing this. I should be getting 153 milliamps when turned on, and 0 milliamps when turned off. If I check that in Circuit Lab, run a time domain simulation, here's the voltages. So this is your output of the pipe timer. It's going 0 volts, 5 volts. This is the voltage at the base. It's 0.7 volts when turned on. And this is the voltage at the collector, 0.2 volts when turned on. So that checks out. And it's not exact. It's not going to be exactly 0.7 volts. It's 836. Again, the 0.7 is kind of a ballpark figure. It'll be close to 0.7 for silicon diodes. Depends on current. Yeah, 0.8. And the 0.2 volts when saturated, again, is just kind of a ballpark guess. Close to 0, but not quite. So it's pretty close to 0. Tells me, yeah, it's pretty much saturated. Here, like this guy, with 200 ohm resistors connected in series. Take one to ground. The other one to the output. The output. It's really quiet. And instead, if I use the transistor switch, that's my transistor switch. Here's the 20 ohm resistor, along with the current. I get a loud sound. Take the second transistor.
Okay, so that verifies that my speaker is working. I've got my output as a square wave. The transistor is tied to ground. I can make the really loud, annoying sound. So now let's add a comparator. I want the speaker to turn on at a given temperature. So if I want to turn on at 50 Celsius, I first have to calculate the resistance. So plugging in the equation for the thermistor, 50 degrees Celsius is 362 ohms. Pick a resistor close to 362. I chose 330. By volts division, I want to turn on at 2.6 volts. There's my offset. And to go to the plus minus input, for the thermistors, the resistance drops with temperature. So I want this to be on at really high temperatures, so connect to the minus input. When it's really hot, this is small, voltage goes small. V plus is more than V minus when it's hot. So here the speaker turns on. I could simulate that in Circuit run the simulation, and the on voltage is the same as the off voltage. That's a comparator. Should look like this. Should be both turning on and turning off at 2.618 volts. That checks out in simulation. Then in hardware, I can sit there, run the circuit, heat it up, see what temperature turns on, cool it down, see what temperature or voltage it turns off. They should both be the same. Right here, this is an on-off switch. When I take the base and tie it to 5 volts, this one turns on, this turns on the speaker. So here's my manual, connect to 5 volts, on, disconnect, on, disconnect. With that, I can then take it to a comparator. The comparator is this guy. When the voltage, here's the thermistor. Voltage divider. When that goes above the V minus, which is set to 4 volts, the speaker turns on. So when it gets hot, let me pause for a second. Now I'm showing the voltage on the thermistor. As it warms up, goes above 2 point. As it warms up, the voltage will drop. When it drops below 2 volts, the speaker should turn on. Here's the hairdryer. There it turned on. I let it cool down. When it goes above 2 volts, it should turn on. Volts-ish. Okay, and here's what the circuit looks like. Here's my 555 timer. First transistor. This is the base resistor, 1K, turning it on. Here's the second transistor. Here's the 1K resistor coming from the comparator. And what the pot does is I can adjust that to adjust the on-off voltage. Now the problem with the comparator is the on voltage is the same as the off. So right at here, I get a lot of chatter. Turn the speaker on and off, and you may not necessarily want that. Toggling a pump on and off burns out the pump. So one way to change that is to add a Schmitt trigger. That's this guy right here. What this does is, in terms of temperature, is going to do this. I want to turn on at one temperature, turn off at a different one. I want the on temperature to be 55 C. Off temperature to be 45 C. Well, I've got to convert temperature to resistance. That's the thermistor. convert resistance to voltage. That's the voltage divider. And the net result is, with these two, the on voltage is 2.38 volts. Off voltage is 2.85. Now, since the on voltage is less than the off voltage, connect to the minus input. The on voltage is your offset, and the slope is the gain. Output changes by 5 volts when the input changes by 0.5, 10 to 1. So make this a 10 to 1 ratio. There's my Schmitt trigger. Have that drive the second stage. It should now turn on at 2.38 volts, turn off at 2.85. If I simulate that in Circuit Lab, I can see that the on voltage, actually this is the off voltage, is different than the on voltage. On is less than off because I connected the minus input. And you have this little dead zone. If it was off, it stays off. Once it turns on, it stays on until it reaches the off voltage. And that checks out. Then in hardware, if I build it, I can sit there and measure what voltage it turns on, which voltage it turns off. Resistor right here, that's my positive feedback for Schmitt trigger. Should turn on at 2 volts and turn off at a different voltage, a higher voltage. That's the hysteresis. So turning it on. Well, it should turn on at one voltage, turn off at a different one. So that's homework set number 5 for ECE 320.